In the last video, we looked at an example of tickets sold and money, and it was an equation in the form y equals mx that passed through the origin. In this activity, we're going to look at an example of a line that does not pass through the origin. You can see in this graph right here, this line is not passing through the point 0, 0. So in this scenario, Emily starts babysitting and charges $10 for traveling to and from the job, and then $15 for each hour she babysits. The graph below illustrates this scenario. All right, so here we have the time in hours that she's babysitting and the amount of money earned in dollars. Part A, find the coordinates of the point where the line intersects the vertical axis. What does this point represent in this scenario? Part B, what is the slope of the line? Include units in your answer. What does this number tell you about the scenario? All right, I'd like you to pause the video and answer those two questions and restart it when you have your answers. Let's take a look at part A. So the coordinates of the point where it intersects the vertical axis is right here, which is over 0 up 10. So what does that point represent? What in the scenario? Well, it represents the fact that she charges $10 for traveling to the job. So we call this an initial cost, some kind of an upfront cost before the job even starts. So she has an initial cost. If you didn't write initial cost, that's fine. Maybe you wrote travel cost or something like that. That's fine. All right, B, what is the slope of this line? So to figure out the slope, let's look at this a couple different ways. Let's find some more points on this line. So I'm looking at this line. I'm looking for a nice point right there. That looks like a nice point. So that point is over 2 up 40. Let's see. Here's a nice one. That point is over 6 up 100. So we could use these points to either do our y minus y over x minus x, change in y over change in x, or we could use the graph. Let's look at it both ways. So one way to find the slope is to do the subtraction. 100 minus 40 over 6 minus 2. So that's 60 over 4. Now, if we include units in this, remember the 100 and the 40 were dollars, so that's $60. And the 6 and 2 are hours, so that's 4 hours. 60 divided by 4 is 15, so my units are dollars per hour. Well, what does that represent? That's how much she charges, right? $15 per hour. Now I could have used any 2 points on this line. I could have used the 0, 10 and the 240. As a matter of fact, let's use that and do the slope doing the rise over run. Let's use those 2 points. So using those 2 points, we went from $10 up to $40. That's a rise in $30 here. And a change or a run in hours from 0 to 2, so that's 2 hours. So looking at that, the slope is the change in the dollars divided by the change in the hours, which is again reduced down to $15 per hour. All right, pretty cool. So that was Emily. This is how Emily charges for babysitting. Let's look at number 2. Beth also is a babysitter, and she charges $15 per hour she babysits, but she doesn't charge anything for transportation. If Y represents the amount earned in dollars and X represents the time spent babysitting in hours, write an equation describing Beth's earnings. Sketch a graph of the equation on the grid above. All right, so Y is the amount she earns in dollars, and she charges $15 for each hour of babysitting. So we're going to take $15 times each hour, which is represented by X. Now we're asked to graph up here Beth's line. So we have Emily's line up here. So this is Emily. Okay, so let's graph Beth. Well, if Beth babysits 0 hours, then she's going to get $0. Let's see, after 2 hours, she'll have $30. Let's plot that point, so 230. After 1 hour is 15. We could try to plot that one, maybe about right there. I'm sort of estimating here. After 4 hours, 4 times 15 is 60. That's going to be right there. 6 times 50 is 6 times 15 is 90, right? So maybe about right there. Okay, let's connect those points. And we can see that these lines appear to be parallel. Let's see how close I estimated my points here. That's pretty good. Okay, so that is Beth's graph. Now, what is the slope of Beth's line? Doesn't ask us that, but I'm asking you. What is the slope of Beth's line? It's the same thing, right? It's still going up $15 for every hour. It's going up $15 for every hour, up $15 for every hour. All right, so if Beth has the same slope as Emily, then these lines are going to be parallel. It's the same rise over run. They're not going to ever intersect each other, which would make sense. Emily would always be $10 more than Beth because they charge the same amount per hour, but Emily's charging that upfront $10 fee for travel. So no matter what time frame you pick, say you pick 4 hours, Emily should always be $10 more. So Beth is $460 and Emily is $470 because of that $10 charge. All right, so we're going to complete the table below. And let's see if we can write an equation here. So we had Beth's earnings was y equals $15 times x. Now what about Emily's earnings? What would her equation be? Her equation is going to be y equals what? Well, she's still charging $15 per hour, but now she's adding on a $10 fee. So to find Emily's earnings, we're going to take, I'll take that dollar sign out, 15x plus that $10 travel fee. All right, take a second, pause the video, complete this table, and then we will talk about number 4. Okay, check your numbers, make sure you have those right. Now let's talk about number 4. Are Beth's earnings proportional to the time she spends babysitting? Are her earnings proportional to the time she spends babysitting? So what we're looking here is for that constant of proportionality. So what we want to do here is we want to take the earnings and write a ratio with the earnings on the top and the time on the bottom. So let me write that out. So we're doing earnings or money over time. So we're going to do that for both Beth and Emily. And I just left room to do it here in the table. So for 0, she earns $0 for 0 time. That's a little weird. Okay, let's do the next one. So she earns $30 for 2 hours of time. That's the 15. $90 for 6 hours of time. That's 15. $195 for 13 hours of time, and that is also 15. 0 divided by 0 is undefined. We won't talk about that one. Okay, let's do Emily. So same thing, if I do Emily's earnings divided by time. So this is going to be 10 divided by 0, which is undefined, so we won't talk about that. Let's do 40 divided by 2, right? She did $40 for 2 hours because she had that $10 fee. So that comes out to be 20. 100 divided by 6. So that comes out to be 16.6666. Let's just round that to 16.7 because remember, we're doing dollars divided by hours. So this is really a money unit per hour. And then 205 divided by 13. Let's see what that is. And that comes out to be 15.77. So since these ratios are not equal for Emily, then Emily's earnings are not proportional. Emily's earnings are not proportional to the time spent babysitting. Now let's think about why that is. And Beth's are. Beth's are, I'll just say. And you can finish writing that sentence if you want. Okay, what's happening here? Well, Emily's charged $10 up front, right? So if you get Emily for 2 hours of babysitting, you're going to have to give Emily $40. So you've really paid her on average $20 per hour. And the reason it's not $15 per hour is because you had to pay an extra $10 in there over those 2 hours. Now, the longer that you have her babysitting, let's say you have her babysitting for 6 hours. Well, now that $10, that initial cost, is divided amongst those 6 hours. If you take $10 divided over 6 hours, you're going to get $1.67, and that $1.67 is added on to the $15 per hour to give you this average cost per hour. Makes sense? If you have her working 13 hours, then this $10 initial fee is divided over those 13 hours, which is only 77 cents an hour. So the more Emily works, these numbers here are going to approach $15 an hour because you're distributing this initial cost over more and more time. Beth, on the other hand, because she had no initial cost or no upfront cost, her money divided by her time is always going to be $15 per hour. So we see this relationship here when we have an equation. Let's go back over here to the previous page. When we have equation in the form y equals mx with no initial cost added on, and that graph goes through the origin, then we're going to see you could take the table and divide these, and you're going to get that constant of proportionality. If there's anything added on to this, like we saw with Emily, she added on a $10 fee, then you're not going to see these earnings, these values in the table be proportional to each other when you divide and find these ratios.